Okay, so today we're gonna learn, is it rational? Yeah, rational functions. Yeah, okay. So the first thing you want to do is do an example. So we're gonna do, as an example, f of x equals x squared minus 7x plus 12 over 2x squared minus 5x minus 3. Okay, so the first thing you want to do is to find the y-intercept. So in order to find the y-intercept, you'd want to make everything into 0, all the x's. So basically it's going to be f of x, make that a 0, so then it'd be 0 squared minus 7 times 0 plus 12 over 2 times 0 squared minus 5, 0 minus 3. So basically what you get after that is negative 4. So what you use with the negative 4 is you take the graph and you go to the y-axis and you place a negative 4. So we're going to guesstimate and put it right here. So we're going to make the graph as we go along. Okay, so after you do that, you want to simplify this so you can find the any removable discontinuities. So basically, we're just going to shorten that. So the removable discontinuities. So basically what you want to do is you simplify it. So we're just going to quickly do that. So f of x equals x minus 3, and then x minus 4, and then 2x plus 1, and then x minus 3. Okay, so basically you can cross out these, and then your final thing is fx equals x minus 4 over 2x plus 1. So that's going to be your shortened of the formulas. Okay, so the next thing you need to do is find the x-intercept. So in order to find the x-intercept, so you need to use the formula that we just got from here, and we use the numerator of it, and then you set it to 0. So it'll be x minus 4 equals 0, and then x equals positive 4. So basically on our graph here, it's just going to be positive 4 on the x-axis. So roughly right there. Okay, cool. So the next step that we're going to do is to find any horizontal asymptote. Oh, no. We're going to find the removable discontinuity now. So we're going to bring this, and we're going to bring that down here. So we're going to find that now. So we crossed out the x minus 3, so we're going to put that here now. So we're going to use the f of x equals x minus 3 equals 0, and then x equals 3. That's going to be important later. So now we're going to plug in this 3 into the formula right here, and that's going to be f of 3 equals 3 minus 4 over 2 times 3 plus 1. And that's going to give you negative 1 over 7. So what these two numbers mean is that from right here on your graph, you're going to go 1, 2, 3 places, the x-axis, and negative 1 over 7. So that's roughly going to be here. And we're going to keep it an open circle, because the removable discontinuities mean that it's like during your graphing, it's not going to be there. Okay, so we're going to flip the page. Okay, so the next thing that we're going to do is to find the vertical asymptote. Okay, so in order to find the vertical asymptote, you want to do basically the limit of x equals to infinity, and you do x squared minus 7x plus 12 and over 2x squared minus 5x minus 3. And you basically just leave all that and you just concern with this. So the limit x to infinity, and then that's going to equal, so you cross that out and that out, so that just gives you 1/2. So basically what you do with this 1/2, you basically just state it as y equals 1/2, and what you do with that is you place it on your graph like so. So you're gonna place it That's the horizontal asymptote. Oh wait, is this is a horizontal asymptote, my bad. Okay, so basically, you're just gonna plot like so. And that is roughly 1/2. Okay, so now we're gonna find the vertical. Vertical asymptote is sort of similar. So we take the 2x, where is that from? Okay, so we're gonna, in order to find the vertical asymptote, we use the denominator from the last formula from the fx, and then we just use the 2x plus 1, and we equal that to 0. And basically, if you do the math, x equals -1/2. So that gives us the vertical asymptote. And that basically, what you do is you take this, and you just roughly hit or miss. That's roughly the graph for -1/2. Excuse me. Okay. So now we have to find the intermediate behavior. In order to do that, you have to do the limit of the -1/2. So we're just going to shorten it. Intermediate behavior. So in order to do that, you have to find the limit of x to -1/2 positive side, and the limit of x to the -1/2 to the negative. So these are going to be functions, and if you just plug these into the equation of the beginning, you will get the -1/2, this as a negative and this as a positive, which means that the negative infinity, it'll end as downwards and upwards. So that'll be count like at the end of when we finally graph it. Okay, so next we have to find any point where the graph crosses out, like crosses the horizontal asymptote. So it's like, just find any points. So find points. Alright, so basically what you do for this, you make the horizontal asymptote equal to the f of x. So what we do the 1/2, that was the horizontal asymptote, and we equal that to x minus 4 over 2x plus 1. And if you do the math, that gives you 2x plus 1 equals 2x minus 8. Sorry, 8. And then that gives you 0 equals 9, but that doesn't work. So basically, what that means is that there is no place it crosses horizontal asymptote. So basically, on the graph, what that means is it's not going to cross the x-axis. So lastly, we are just going to graph it. So with using all our knowledge, it's basically going to look something like this. So it'll roughly, because of the end result, because these lines are the guidelines and they don't touch, and then this, it follows the x, and it doesn't go through that because that was the removable discontinuity, and it just follows these lines. Okay, and we are done.